Hello Porters, Mr. Kane here. Get ready to talk to you about how to do mole conversions. Um, Before we get started here, I just want to remind you, or make you note, put this in your notes. We learned last week 1 mole is going to be equal to 6.02 times 10 to the 23rd particles. Now I know that sometimes in some places they say it's 6.022 times 10 to the 23rd. And sometimes they say 6.02 times 10 to the 23rd. I don't really care which you use. I tend to use the shorter version. And particles, of course, refer to things such as atoms, molecules, or formula units in chemistry. The other idea that we learned last week in school was that 1 mole is going to be equal to what's known as the molar mass. That's found on the periodic table. So for instance, hydrogen, 1 mole of hydrogen, just H, would be 1.01 grams, because that's what it says on the periodic table for the average atomic mass. Notice it's units of grams for a mole's worth. The last ratio that you need to know, and you'll need to write this one down because we didn't learn it last week, is that 1 mole is equal to 22.4 liters if you're talking about something like a gas that's hydrogen. So very good question I got last week in class is, how do you know how much hydrogen you have if hydrogen always escapes? If you have a hydrogen balloon, it's lighter than air. You can't weigh it out. That's a very astute observation, right? So sometimes there are things that we can't weigh easily, and we can volume them out because gases, we know, take up 22.4 liters at certain conditions, which is known as standard temperature and pressure. That is to say that we need a certain temperature and pressure at which a gas is going to take up that 22.4 liters. Many of you realize that when you take a balloon outside on a cold day, it will get smaller, so the temperature does matter for volume. Pressure also matters for volume. If you were to take a balloon up into the mountains, or if you were to take it down underwater, it's going to change its size as well because of the different pressures. So at any rate, we're going to be using these 3 ratios, okay? And I'm going to start out by doing a couple of problems with you. I'll leave a few for you for homework, right? I've got a few that I want to do. So the first is, how many moles of cobalt are in 6 times 10 to the 9th atoms? So the way we're going to do this is we're going to use dimensional analysis, which we learned first semester, but we haven't practiced much since. I'm going to remind you that the way that you use dimensional analysis is pretty simple. You start with the number that they give you and its unit. And then after that, we use a ratio, right? Whatever's on top of the ratio has to wind up going on the bottom of the ratio because we want these two things to cancel each other out. So I'm going to put the word atoms on the bottom, and I'm going to check which of my ratios that I can use. Do I use the ratio that talks about particles, the ratio that talks about mass, or the ratio that talks about volume? It turns out that an atom is a particle, so I'm going to use this ratio here. So I can go from atoms to moles. How many moles? Well, the ratio says 1 mole is worth 6.02 times 10 to the 23rd atoms. So I'm going to write my 6.02 times 10 to the 23rd right there, okay? What ultimately happens if I'm multiplying this ratio here by this ratio here is that atoms is on top and is on the bottom. So I'm going to get to cancel it out. That leaves me with moles, which is the units that I want. So basically what I have to do is what I've outlined. I'm going to take 6 times 10 to the 9th. I'm going to multiply it by 1. And then I'm going to divide it by 6.02 times 10 to the 23rd. If I've got a calculator here, I can even do that. Check this out. Pro tip, find where the times 10 to the power is on your calculator again. For most of us, it's the EE button. So I'm going to type in 6.00, and then I'm going to type that EE button. TI calculator, say E, and then I'm just going to put in a 9. Now that E on the screen on a TI calculator means times 10 to the 9th. If you've got a graphing calculator, it might actually say times 10 when you hit that EE button. Okay, please do not use times 10 and caret, because that's not the same thing. You're going to need a heck of a lot more parentheses. Your calculator is going to misunderstand what you're doing. So I'm just going to go ahead and do this. Divide by 6.02 times 10 to the 23rd. I'm going to hit equals. And it's always safest to round to 3 or 4 non-zero digits. So I'm going to look at my 9, and my 6. That's my first 3 digits. I'm going to use my 4th digit to come back and round. So the 6 is going to tell me to round the 6 up. So I'm going to write 9.97. And I can't forget about this part at the end over here. It says times 10 to the negative 15th. So when I write it, I write 9.97 times 10 to the negative 15th power. Now this is just a number. We need some units that go with it, and that's going to be moles. I want to show you guys why we don't want to use the caret. So 6.00 times 10 caret 9, right? That's 6 times 10 to the 9th. Divide by 6.02 times 10 caret 23. And you'll notice that my calculator came up with the exact same answer, except for the scientific notations completely different. It gave me 9.97 times 10 to the 31st power. Now we got to look at the math here. We've got a relatively big number, but we're dividing it by an even bigger number. Do we expect it to get smaller or bigger? Right? What happens if I take a number like 2 and I divide it by 100? It gets smaller, right? So the fact that this answer, 9.97 times 10 to the negative 15th, is smaller than my original answer makes me think that this answer is right. When I look at this answer, 9.97 times 10 to the 31st, this answer is much bigger. It doesn't make sense for trying to take a number and divide by an even smaller, by an even bigger number to get an even bigger number. That would be what we call multiplying. So this method of using the caret means that you have to put some parentheses in so your calculator doesn't misinterpret what you want. I'm going to put it right here after my divide. I'm going to put a parenthesis so that everything on the bottom is inside of a parenthesis. Notice now my calculator understands what I wanted to do and gives me the right answer. So, summary, use that EE button. Okay. I'm not going to show that again, but I will show you how to do some other problems. This one might have made a little bit of sense to you. I want to show you something called a Mole-Pellar for the next problem to help guide you as you're going along. How many moles of calcium, so we're going to go for moles of calcium, are present in 77.4 grams. Okay, so again, I'm going to start with the number they give us, 77.4 grams. I'm going to multiply by a ratio, and I know that I've got to put grams on the bottom of my ratio. Now, I'm going to show you this other screen here that's got what I call my Mole-Pellar. Check this out. Mass, we can use mass to convert to moles because there's a way to do this. I want to divide by the molar mass according to what it says here. If I have volume, I would want to divide by 22.4 to get to moles. If I was in moles, I could move down and multiply by 6.02 times 10 to the 23rd to get particles. Or if I was in particles, I could move towards moles by dividing by 6.02 times 10 to the 23rd. So this Mole-Pellar can help us out quite a bit. The problem that I've got right now is I'm starting in grams, that's mass, and I want to be in moles, that's here. So I want to follow this pathway. This pathway tells me I need to divide by molar mass. So check this out. If I'm using my paper, 1 mole is equal to molar mass. So my grams are over here. My mole is up here. It's going to be 1 mole is equal to a certain amount of mass. I need to know the molar mass of calcium for this. I can find the molar mass of calcium. It's right here, 40.08 grams. So I'm going to put 40.08 grams right there. Grams and grams cancel, leave me with moles. So 77.4 grams will get divided by 40.08 to tell me how many moles we have. 77.4 divided by 40.08. And again, it's always safest to round to about 3 non-zero digits. So I'm going to pick out the first three, 1, 9, and 3. And I'm going to use that 1 to round. The 1 tells me to leave the 3 alone. So I'm going to have an answer of 1.93. Double check that I don't have scientific notation to worry about, which I don't. So this is going to be about 1.93 moles. If I want, I can employ the same sort of thought process to check my answer as I did with my first problem. I can look and I can go, hey, a number like 77.4, and I'm dividing by almost half of it. Maybe I'm going to get an answer around 2, right? And I got an answer kind of close to 2. All right. Question 3 here. Notice I needed the molar mass for calcium up here. Question 3 here asks me to find the molar mass of a compound instead of an element. Compounds, you need to make sure that you're writing the right formula. So magnesium nitride would be made up of magnesium and nitrogen. Remember that we have to worry about the charges. So something like magnesium is a +2 charge, and something like nitrogen is a -3 charge. So if I'm penciling that in up here, +2 and -3, that means it's not going to take just 1 magnesium and 1 nitrogen. I'm going to need 3 magnesiums and 2 nitrogens. All right. So when I actually calculate my molar mass, magnesium is 24.31. So I'm going to take 24.31 and I'm going to multiply that by 3. I'm going to add to that my nitrogen, which nitrogen is 14.01 grams. 14.01, I'm going to multiply by 2. Let's find out what that gives us. 24.31 times 3. I'm going to hit equals, I'm going to hit plus, and I'll do this in parentheses. 14.01 times 2. I get 100.95 grams. And that's a mole's worth of stuff. So 100.95 grams. Some people like to say 100.95 grams per mole. Or some people like to say 100.95 grams is equal to 1 mole. Either of those is fine. Okay? I tend to prefer this for a molar mass. I tend to like my answers not having equal signs in them. All right, let's see, where are we at? We're at problem 3 here. How many molecules of ethane are present in 0.334 grams of ethane? So here, I've got 0.334 grams. I'm going to do this. I'm going to write my ratio. I'm going to put grams on the bottom because I know grams has to be on the bottom. Grams is here, so I'm going to have moles on top. And notice it's going to be 1 mole. Question is, what's my molar mass? My molar mass is the molar mass of ethane here, which I'm going to do without showing it by writing. Carbon is 12.01, so I'm going to multiply that by 2. And then each of the hydrogens are 1.01, so I'm going to add 6.06 because I can do that in my head. And I'm going to get 30.08 grams as a mole. Now, did I answer the question? The question asks how many molecules there are. So no, I didn't answer the question. So I'm just going to continue my dimensional analysis. I'm going to put moles on the bottom. And on the top, oh, hey, I can convert moles to whatever the heck I want. Molecules are over here, so I'm going to use molecules because that's what I want. Let's see. It's going to be 1 mole is equal to 6.02 times 10 to the 23rd molecules. So it's 6.02 times 10 to the 23rd molecules. And let's see. The math I'm doing in my calculator, 0.334 divided by 30.08 multiplied by 6.02 times 10 to the 23rd. Notice I used my EE button that time. I'm getting 6.68 times 10 to the 21st. The 4 is going to round the 8 and leave it alone. So 6.68 times 10 to the 21st power. Now let's see, grams cancel grams, moles cancel moles, so the units that are left are molecules. Let's see, does this answer make sense? I'm taking 0.334, I'm dividing by 30, so I'm expecting to get a much smaller answer, right? Then I'm multiplying it by a really big number, so I'm expecting it to get really big. I got a really big number, so I think I'm pretty confident that this looks right. All right, how many nitrogen atoms are in a one point? I think I'm going to, should I skip this problem? This is a doozy. I'm going to come back to 5. And we're going to look at 6 first together. Okay. How many water molecules are present in 2.56 grams of water? 2.56 grams, right? Next thing that I'll do is I will write grams on the bottom. I think I might be writing a little bit under the screen here. Let me see. Yeah, that's better. Okay, so grams goes on the bottom and moles goes on the top, right? Because there's a certain number of grams in a mole. It's always going to be 1 mole, and the number of grams is going to change. This is water, which I know the formula is H2O, so oxygen weighs 16. Each of the hydrogens weighs 1.01, so this is going to be 18.02. I know this one by heart because I've used it so much, right? That leaves me with moles, which I want molecules. So I'm going to take this one step farther. Grams got canceled, now moles are left, so I want to put moles on the bottom. Molecules can go on top. Remember, my ratio is 1 mole is a certain number of molecules. It's going to be 6.02 times 10 to the 23rd molecules. So that moles cancels, I'm left with molecules. Let's see, so my math is this, 2.56 divided by 18.02 multiplied by 6.02 times 10 to the 23rd. Again, notice I used the EE button for my times 10. And I got 8.552. The 2 is going to tell the 5 to leave alone. So 8.55 times 10 to the 22nd. 8.55 times 10 to the 22nd molecules. Again, I'm thinking that the best practice is to check and make sure the math works out. I'm taking a number close to 3, dividing by 18. It's going to be close to 6. Then I'm taking 6 and I'm going to multiply by 6.02 times 10 to the 23rd. That's going to be really, really big, right? Oh, actually, 2 divided by 18 is not 6. It's like 9, right? It's going to be 0.9. Hang on. 2 divided by 18 is, oh, it's smaller, right? It's like a 1/10. So 1/10 times Avogadro should get us a slightly smaller number. Okay? All right, let's see. Where are we at? We got this one problem left that's a real doozy. Oh, hang on. Before I show you the doozy, let me go back to the Mole-Pellar real quick and just point out what happens with the Mole-Pellar with problem 6. With problem 6, we started out in mass, and we wanted to wind up in particles. We wanted to wind up in molecules. So the first thing that I was going to have to do, according to the Mole-Pellar, was go to moles by dividing by molar mass. The second thing I was going to have to do was divide, sorry, I said divide and it says multiply. I was going to have to multiply by 6.02 times 10 to the 23rd by Avogadro's number to get to molecules. So notice, this is exactly what I did here. I did exactly what the Mole-Pellar says. I started in I started in grams, I divided by mass, and then I multiplied by 6.02 times 10 to the 23rd. So the Mole-Pellar can help you out a little bit in confirming that you're doing the steps right. I prefer to look at the steps. You're not going to be able to use the Mole-Pellar on the test unless you can rewrite it as soon as you get your test. So it's best to know how to do your work this way. As you can see, this is a skill. It's something you have to practice. And the more you do it, the better off you're going to be. I'm going to do this one last problem with you. All right, so it says how many nitrogen atoms there are in a 1.68 times 10 to the 4th gram sample of this urea. Okay, now I'm going to start in the same place that we've always started. I am going to convert, because I start in grams, I'm going to write grams on the bottom and moles on the top. Again, we can go from grams to moles. It'll be 1 mole. The amount of grams, I've got to figure out the molar mass here, right? So I'm going to do it this way. I'm going to take my 14.01. I'm going to add 2.02 because there's 2 hydrogens inside. And then notice there's 2 of these, so I'm going to multiply it by 2. Then there's still a carbon and an oxygen to add in, so I'll add 12.01, and I'll also add 16.00. So I'm getting a molar mass of 60.07. 60.07. Grams cancels grams. And my moles are going to get written on the bottom because moles are left on top. Now, what can I write on the top is particles. It all depends on what kind of particle this is. This is a formula unit. Because it's ionic. I'm going to write 1 mole, because 1 mole is equal to 6.02 times 10 to the 23rd formula units. So I get to write 6.022 times 10 to the 23rd formula units. All right. Now, the tricky part about this problem is I end in formula units right now, but they want nitrogen atoms, which means I have to come up with another ratio. I have to talk about how many formula units there are and how many atoms of nitrogen that there actually are in that formula unit. What's a formula unit? Oh, check this out. This is a formula unit right here. How many nitrogen atoms do you see in that one formula unit? That's right, I see 2 also, because there's 1 inside the parenthesis, but the parenthesis gets multiplied by 2. So there's 2 nitrogen atoms in every formula unit. Right? So the math now is going to be this. I'm going to take my 1.68 times 10 to the 4th power. I'm going to divide by 60.07. I'm going to multiply by 6.02 times 10 to the 23rd, and then I'll multiply by 2. All right, 3.3. Now there's a 6 after the 3, but there's a 7 after the 6, so I'm going to round up. So I'm going to say 3.37 times 10 to the 26th power atoms of nitrogen. I'm being sure to label that because I want to be sure that I know what the answer relates to. All right, I think that should help you out. And I think the assignments on the back here, we're going to wind up having you do 7 through 11. Good luck.